Hi all, welcome to the YouTube channel Mechanical Engineers. So in our previous video, we covered the positive displacement pump. We covered reciprocating pumps. We covered rotary pumps. So in our today video, we will be covering the dynamic pressure pumps, which include the centrifugal pumps and its types. Centrifugal pump basically consists of stationary pump, casing, and impeller mounted on the rotary shaft. The pump's casing provide a pressure boundary for the pump and contains the channel to properly direct the suction and the discharge flow. The pump casing has a suction and the discharge penetration for the main flow path of the pump, and normally has a small drain and the vent fitting to remove the gases trapped inside the pump. So basically, as you can see, this is a centrifugal pump. It has a casing, an impeller, and a rotary shaft. And then there is a suction, which is just horizontally to the impeller, and there is an discharge, which is at just 90 degree of the suction side. The fluid enters from here, and after getting pressurized, it exits from the outlet port of the pump. This is again that thing, the pump casing guides the fluid from the suction connection to the center or the eye of the impeller, forcing it to the outer periphery of the pump. So these veins, as you can see, it impart a radial and a rotary motion to the liquid and forcing it to the outer side of the pump. So these are the impellers. As you can see, the impellers of the pumps are classified based on the number of the points that a liquid can enter into the impeller and also on the amount of webbing between the impeller blades. The impeller can either be single section or the double section. A single section impeller allows the liquid to enter the center of the blade, but only from one direction, and double section impeller allow liquid to enter at the center of the impel blade from both the sides simultaneously. As you can see, I will just zoom it out. This is a single section impeller, and this is a double section impeller. As you can see, single section impeller has allowed the liquid to enter from the one side, and the double section is allowing the liquid to enter from both the sides of the. So operating point. So operating point, every centrifugal pump has an operating point, and it is that point at which the force of the pump balances the resistive force of the system. So this occurs at an intersection point between the pump performance curve and the system resistance curve. If the flow accidentally increases or decreases beyond the operating point, the pump force becomes lesser or greater than the system resistance, and the flow either decelerate or accelerate till the forces get balanced again. As you can see, this is an operating point of this pump, and at this point, the pump actually delivers the required volume. And if accidentally, if this any resistance, uh, if the flow accidentally increases beyond this operating point, the pump may deliver flow issues. So how to control the pump flow rate? So basically, there are two methods to control the pump flow rate. If the pump delivery valve is partially closed, the system resistance increases, hence the operating point shift to the lower flow rate. And second, if the motor speed is increased, the HQ curve will change as shown at the diagram. So as you can see here, if the speed is increased, the head versus the operating point is getting shifted. And here, if since the delivery valve is closed, the system resistance is increased and the operating point also shift to the lower circuit. Basically, most of the pump are designed to operate at the best efficiency point. The pump design is held at a single point. That point is called the design point. So when operating the pump at this point, it has the maximum efficiency. So the point is also called the best efficiency point. So when selecting the pump, it is normally targeted to operate the pump at this point. Hence, it is also a normal flow point. The cavitation is the most commonly problem that occurs in any centrifugal pumps. So basically, what happens is if the greater the pump flow rate, the greater the pressure drop between the pump section and the eye of the impeller. And if the pressure drop is large enough, or if the temperature is high enough, the pressure drop may be sufficient to cause the liquid to flash to the vapor when local pressure falls below the saturation pressure for the liquid being pumped. So any vapor bubble formed by the pressure drop at the eye of the impeller are swept across the impeller varies by the flow of the liquid. So when the bubble enters the region where the local pressure is greater than the saturation pressure, farther than the impeller vanes, the vapor bubbles abruptly collapse. And this formation of formation and subsequent collapse of the vapor bubble is called cavitation. As you can see, this is then vapor bubble, and as it collapses, then it causes the problem of cavitation. So cavitation has a significant effect on the pump performance. It degrades the performance of the curve, resulting in the flow fluctuations and the discharge pressure. So basically, to overcome the cavitation issues, the pump should be run at the positive NPSH. The NPSH is the pressure of the fluid at all the point within the pump must remain above the saturation pressure. This is to avoid the cavitation. The quantity used to determine if the pressure of the liquid being pumped is adequate to avoid cavitation is called the NPSH, which is net positive suction. The NPSH available is the difference between the pressure at the suction and the saturation pressure of the liquid being pumped. The NPSH required is the minimum net positive suction pressure head necessarily to avoid cavitation. Preventing cavitation, so basically you can reduce the cavitation by raising the suction head level. So basically, if you place the tanks above and the pumps below, then you are indirectly increasing the NPSH of the pump. Then another way of improving NPSH is decreasing the losses in the suction tank. This means placing the pump as close as to the suction tank, and although theoretically its operating point is not affected by the place across the pipeline, to decrease the suction length and also increasing the suction pipe diameter to decrease the losses and the kinetic energy. Further, finally, one more point is excluding any unnecessary fittings like elbows and other kind of bends used on the and using the suction walls of the types that make the minimum losses when fully open. So thank you for watching. This was an last session for the pumps category. We shall be covering more in our next video. Thank you.